How to make 2-in-1 image in Blender? This question was asked on the subreddit Blender Help. As a curious person, I looked at the answers and wanted to try to apply them, but instead of Blender, we will do it with Three.js. So, what problem are we solving exactly? Remember when you were still a student and your parents coming to check if you are studying correctly? From their point of view, they could see you learning mathematics, while you were learning much more interesting topics. Let's discover how to create it with Three.js. To make it more interesting, we will use this opportunity to discover the 3 shading language named TSL. Before starting, a huge thanks to our sponsor, 3D AI Studio, the ultimate AI tool for 3D web developers, with cutting-edge features like 3D model generation from text or images, AI texturing, and remeshing. It's perfect for bringing your Three.js projects to life, link in the description. Let's start by creating our project, including Three.js, WebGPU, and React Fiber. For that, I created the starter pack on GitHub. Link in the description, copy it. In a terminal, git clone, paste the URL, and type the folder name you want for your project. Let's name it R3F Lenticular and clone. Once done, let's open the folder and then yarn to install the dependencies or npm install and yarn dev to start the development server. We can open it and we have this cube and we are able to rotate around thanks to the code located in app.jsx and the experience containing our cube and the orbit controls. To display our 2 image, we won't do it on a cube but on a plane. For that, let's change the box geometry to a plane geometry. We will set its size to 1 and 1. And we will change the material to a custom material we will create together that we will name Lenticular Material. To create this material, let's go to Components and name it Lenticular Material.jsx and let's declare it. Export consts Lenticular Material. We will define the props later, but what we will return is a mesh standard. But because we want to use TSL, it will be a node material from Three/WebGPU. And for the moment, we will use color is equal to pink. Because this is new and React Fiber doesn't implement all the types from a Three/WebGPU, we need to extend it. So we extend from React Fiber mesh standard node material from Three/WebGPU, which allows us to use the material this way, in a declarative way. It's something we don't need to do when we are using a mesh or a plane geometry, because it's already done internally by React Fiber. We can hope in the future everything from Three/WebGPU will be done too. Let's save, also do the import here. And let's pray I didn't break everything. Okay, currently it's black, but I set it to pink. Maybe it's because I didn't add light. To avoid it, in the experience, let's add the environment component with the preset sunset, which is my go-to. And we now have the plane in pink. Perfect. Now what we want to do is to create a custom logic in our material to handle an image from the left and from the right. To do this, we will create a custom shader, but the way we do it with the node material is very different from the custom shader we are used to do. Instead of writing GLSL code, we will declare nodes from the Three.js shading language. You have this huge page explaining how it works and how to do it. I highly recommend you to read it to understand why they did it and how to use it properly. As a shortcut, you can use my course React Fiber, the ultimate guide to 3D web development. There are 2 dedicated lessons to TSL and WebGPU. Here it is. It goes from how to create a project using WebGPU, which is the starter pack you already used, but in it you have the explanation on how it works, and also a comprehensive project on how to use TSL and nodes. Link to the course in the description. Let's see with React Fiber how to add our nodes into the mesh standard node material. What I like to do, this is my implementation, maybe there are others, is to declare the nodes and also the uniforms in a use memo. So it doesn't change at every re-render, but only when you need to. Inside, we create uniforms that we will assign later, and we return the different nodes we need. But first, the uniforms. So we are sure we have access to it outside our use memo, and then the different nodes. Let's make one very quickly, nodes, and we will use color node. It will be equal to mix, so we are using TSL functions, mix of color of red, color of blue. Again, it's TSL function that will create a red and blue color. And for our mix, to determine which one it will use, we will use uv.x. Again, a TSL function to have access to our UVs. Now, to apply the nodes, we simply destructurate the nodes. What it will do is it will pass color node and all the other nodes you could define. Again, for all the different nodes and TSL functions, you have this page 3 shading language with an explanation of all the one variables and how it works. Let's save, and if we reload, we can see we have a nice gradient coming from red to blue, and it was very simple to do it, while with GLSL it will take way many more lines of code. Here the declaration and the syntax is so quick and so straightforward. Now, before creating the effect, what we want to do is not to display simple colors, but instead to display image texture or even video. To generate the images for our project, we will use the sponsor of this video, 3D AI Studio. It is very simple to use and will help us to generate high quality image. Let's go to Image Studio. You have the choice between many advanced models. Let's start with Flux Pro. Let's create different type of image. Let's say because we want to show the contrast between two images, we will want a summer scene. So I tap summer and I will use the prompt add-ons. Here I can click on 3D stylized, and it will help me with ready-to-use prompt for high-quality render. Let's click on Generate, and we have this lovely summer image. Let's download it, and to generate the opposite, let's simply replace summer by winter, and then generate. Perfect. Let's save it too. And if, let's say, you want to generate more alternative at once, you can go to Advanced Settings and choose a higher number of images. Okay, so we have a nice generation of summer and winter images. Let's generate two other images, but in a totally different style. So for this, we'll change the model we use. Let's check what we have. There are many good ones for characters and landscape. Depending on what you want to achieve, you will find what you like. Let's choose Fantasy Forge. Let's type Devil for this one and choose the prompt add-on Epic, adding many keywords and generate. Look nice, but I want something more reddish. So we choose the red and let's try our chance again. Okay, much better, very epic, very Devil. Let's download it and let's generate the opposite. We will remove Devil and red and switch to Angel and generate. Lovely. Let's download it and go back to our project. Let's move the file we downloaded inside public, new folder textures. Let's create a separate folder for each set. Let's name it Evil Angel, another folder Summer Winter, and another one for the videos, Mathematics and Twerk, which are videos I found on tenor.co. Let's drag and drop all the files we need and rename and reorder them. Summer, sorry. Drag and drop here. And then we have the true winter, evil, and angel, I guess. Yep. Now let's load them inside the experience component. Go to experience. We'll have a texture set. We will use Leva with use controls. And we'll add a texture set that will be a drop down. The default value, we can say it will be evil angel. The different options will be evil angel, the summer winter, and mathematics twerk. And let's code a logic to get access to those texture. Const video a is equal to use video texture of textures slash mathematics twerk slash twerk course.mp4. Then for video b, it is mathematics numbers. Then const texture evil angel a will be used texture of this one. Same for the b. This is not the most elegant way to do it, but it is the fastest, and it's to handle videos and images seamlessly. Now we have summer winter, summer.png, and winter.png for summer winter. I hope I didn't make too many mistakes. Const texture a is equal to, then we take the different options. Evil angel, it will be texture evil angel a, summer winter, mathematics twerks. And now for texture b, we do the same. And to get access to the texture, we use the texture set. Okay, and same for texture b. Now we have textures, we can pass them as props to the material. Texture a is equal to texture a, and same for texture b. Let's go to the material. Let's handle texture a and texture b, and let's declare the texture. Const text a is equal to texture from TSL of texture a, and then const text b is equal texture of texture b. And now instead of displaying the color, we will display either texture a or texture b. If we open our project, you can see you have a gradient between the first image and the second image. Unfortunately, you can't change on the fly the texture here. I tried to pass them as uniforms or update dynamically the texture, but it led to crash. Maybe it didn't like to switch from video to image. So instead we will do something ugly, which is to use the texture set as the key to our material, which means when it will change, it will recreate our material with the new textures. Not perfect, but that's a quick solution I found. Let's try it again. Now if we change, we have the gradient between the two. It's not the effect we are trying to achieve, but it's to show you how to load textures, and the videos worked nicely. By the way, it's fun, we have mathematics on top of the twerk. Now let's create the lenticular effect. What it is if we look at the image from the left, we should see only the angel. And if we look from the right, we should see something else, only the devil part. The simplest way and the most efficient way to do it would be to use the camera position, but I wanted to do the physical approach to it, which is if we go back to the answers on Reddit, you have this example here. Lovely drawing, by the way. So you have your plane, and we will move the different faces of the plane, and on those sides we will display one picture, and on those sides we will display another image. So based on our point of view, we will see an image or the other. This is called lenticular printing, and you might have seen some of those in your childhood or anything that is printed this way. You have a lot of explanation on how to do it, but it's actually quite simple. To do it inside our experience, we will need more options to affect what we are doing in the material. we will need the number of divisions we want. Let's say between 10 to 90. Number divisions and the height of the displacement we will do on the faces to create this fan effect or accordion. Let's create heights. Okay. And those ones, we can pass them as props and we won't recreate every time the material. Number of divisions and height. Now inside our material, let's handle it. Number of divisions and the height. We will create uniforms inside the uniforms. We will have U and B divisions. To create a uniform with TSL, you simply create it doing uniform and you pass the initial data you want. In this case, number divisions, and same for U8. And to update the uniforms, instead of passing them as effect and to change our whole nodes, we will simply create a different use effect with the height and the number of divisions. And we set our uniforms. Uniforms.uHeight.value is equal to height. And same for the number of divisions. Perfect. Let's save it. And let's not forget inside our experience to impact our plane geometry, because currently our plane geometry is using one width segment and one height segment, which means we only have one face or two triangles. Instead, we will use the number of divisions on the x-axis to be able to displace the different faces to create this shape we see here. The width segment is the third parameter, and b divisions multiplied by 2. And for the y, the height, we can keep it to 1. Unless you want to do the effect top-down, you can stick it to 1. Okay, let's try it. Let's simply see if it isn't broken. It seems it's fine. If we change, we won't see anything happen. Let's choose a wireframe on the standard material. Now we should be able to see the different segments, so we can adjust it to do more or less the effect. Perfect. We have everything in place to create the effect. First, let's impact not the color with the texture, but instead the position node to say 1 on 2 segment will be up or down. To do this, we will create a new node, the position node, that will be equal to position local. So basically it's doing nothing. We are just assigning its local position. But on top of that, we can move it. We will use add, and we will add a vector 3 with 0 and 0. We just want to change the depth of it. So let's say we put 1 for the moment. It's just pushing everything towards us. To create the shape we want, we can use the UV with the UVX. We will have this curve going from 0 to 1. What we will do is we will take this and we will multiply by the number of divisions we have, let's say 10. And if we use the fractal on top of this, it will repeat the pattern 10 times from 0 to 1. We will use this to say, okay, this vertex is here, this vertex is on top, this one is below, on top, and so on. The code for it is a repeated UVs is equal our UV.x that we multiply by the uniforms, U number divisions, and fract, which is exactly what I show you in the graph. Now, instead of using 1 to push everything, we will use our UVs to do it properly. We will add a mix between two values, our heights, uniforms.uHeight, but we want minus our height. To do this, we can use negate and uniforms.uHeight. So it will be minus uHeight and uHeight based on repeated UVs.x. For each vertex, it will be either 0 or 1, alternating between the first value and the last. Let's try it. And we can see how easily we pushed the vertices forward or backward. Now, if we try to change the number, it works nicely. And if we try to change the height, it also works perfectly. But now what we need to do is on the faces on this side to display one image, and for this side to display the other image. To do this, we create aligned UVs. It will be equal to a step at 0.5 from our UVs. What it's doing is step 0.5 and X. Let's disable it. So if you have a value below 0.5, it will equal to 0. And if the value is above it, it will be equal to 1. We don't want a gradient between our images. We want either one or the other. That's why we use a step. Now, instead of using our uv.x for the color, we will alternate with aligned UVs. And it crashed nicely because we need to import the step function from TSL. Now let's see what we have. If we look from one side, we see this, and from the other, we see the angel. The effect isn't the best at 10. So if we increase to the maximum, we have a better image quality and a nice fade based on where we are. You can also impact the height based on what you like. Let's check the other one, summer here and winter here. Lovely, maybe we can go closer to really see the effect, maybe with the less. Awesome, and the videos. Oh, your parents and what you see. Thank you for watching. I hope you enjoyed this video. Please hit the like button to help this channel be more visible to other creative developers. Thanks again to 3D AI Studio, link in the description. And don't forget to subscribe to not miss my upcoming tutorials. If you want to continue your 3D web development journey, give a look to my course or watch one of my other videos like this one, available here.